Welcome to week 12. Today we'll be looking at mixed and repeated measures factorial ANOVA. Okay, so we are in SPSS here, and you'll see that I have a number of variables created. So these actually match the examples that were in your slides today. So I'm now going to show you how to actually run everything that we looked at in class. Okay, so the first set of variables, so basically here to here is the example for repeated measures factorial, and then these ones here are what we need to run the mixed factorial. So if you recall, a repeated measures factorial ANOVA is a factorial ANOVA where we have more than one independent variable, and the independent variables are categorical, and in all cases the independent variables represent the same people. So what that means is that if we have 20 people in one cell, those same 20 people have to appear in all of the cells. So that means that in SPSS you need to have a separate variable for each of the cells. Whereas in the mixed factorial ANOVA example, where we have one independent variable that is measured as a repeated measure variable and the other one that is independent groups, in that case you only need to have a full variable for your repeated measure, and then you can actually have a variable creating the category for the independent measure. So, and those variables are right here. So if you recall, the example we had used was whether the type of movie, so comedy, drama, action, and the location of where the movie was watched, so either the theater or at home, influenced people's happiness. So like I said, there's one variable for each cell. So the easiest way to do this is to actually name them based on which cell they are. So this is the comedy theater cell. This is the comedy home cell. Then there's the drama theater, drama home, action theater, action home. And through these six variables, we have everything we need to run this particular repeated measures factorial ANOVA. So we'll start with that one. So if we go to Analyze, General Linear Model, Repeated Measures, and I'll just reset everything here so we can start over. So like when we were running the simple repeated measures ANOVA, we have to go back to that same dialog window or the same analyze options when we're running the repeated measure ones. So it's general linear model repeated measures. And before we can do anything, we have to declare what our what our repeated measures factors are. So in this case, since we're doing a repeated measures factorial, we have two factors to declare here. The first is the location of the movie, and it has two levels, either home or theater. And then the other one is, we can call it genre or just the type of movie, and that one, if you recall, has three levels because we have comedy, drama, and action. So we add those, and then our dependent variable is actually happiness. Oops. And so we'll add this here. So once we have the two variables listed up here and our dependent variable here, we can actually click define, and now it's time to start actually building the model. So SPSS based on what we have just declared in the first box, SPSS will generate all the different things we need to run this analysis. So if you look here, you see you have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 2, 3. So what this essentially means is that this first set of ones here is the location, and then the 1, 2, 3 are going to be the movie choice. So based on what we have, our first thing could be comedy theater. That'll be 1, 1, which means that 1, 2 will be drama theater, and then 1, 3 will be action theater. So it's really important to set this up properly. So you have to make sure everything's lined up. So comedy theater we'll put here, and then the next one will be drama theater, and then action theater. Okay, so the 1 is a type of movie, the type of location, and then 1, 2, 3 specifies the type of movie. And we do the same thing down here. So now we have comedy home, drama home, and action home. Okay, so this is set up properly. So now we can set up our options. So if we would like to have a plot, we've done the same way. Usually it's easier to put the smaller, or the one with less levels on the separate line. So in this case, it'll be the location, and then the movie on the horizontal axis. We click add, and this will generate a plot of what's actually happening here, so we can see where the group needs all fall. Post hocs, if you recall from last week, this is the button for post hocs on independent variables. Okay, so independently measured variables. So this would be a good spot to click if you had a mixed design and your independent categorical variable your categorical variable that's measured with independent measures had more than 2 levels. You would click here to get the post hocs for the main effects. So in our current case, we don't have to deal with this, but we'll come back to that after. And then save, there's nothing, and then options. This is where we can generate our post hocs. So we'll click everything here, and if you recall, we want to do Bonferronis. So there won't be any post hocs on location because there's only 2 groups. However, our movie has 3 levels. So if we don't have a significant interaction and we're going to be looking at just the main effects, we will need the post hocs for movie, and since it's a repeated measures variable, we need to have the Bonferroni correction. So then from there, we can click descriptive statistics and estimates of effect size, and we're good to go. So we click OK, and we have our results. Oops, sorry. Okay, let me just fix this. Excellent. So as we can see here, we have location 1 and location 2. So location 1 is the theater, location 2 is home, and then we have the comedy, drama, action, comedy, drama, action. So everything's set up properly. Here we have the descriptive statistics for each of the cells. So we can see that there are some differences in our observed means, and we also have differences in the observed standard deviations. So we'll see if this has any impact on the F statistic as well as the sphericity test. Okay, so looking at our results here for the test of sphericity, we can see that location has no value, and that's because there's only 2 groups, so it's always going to do that. Movie, however, does have an issue with sphericity, so that's not surprising given that this is so much different than this, so that's okay. So what this means is that when we're interpreting the main effect for movie, we need to make a correction. And since this value is smaller than 0.75, we're going to make the Greenhouse-Geiser correction here. And then luckily, or not luckily, but just to note, there are no issues with sphericity for our interaction. So next table, we have our Anova table. And as you can see, there is a separate error term for each of the independent each of the independent variables as well as the interaction. So really there's a separate error term for each of the main effects we're looking at. So looking here, the main effect for location, we can see that it's significant. So it means that there is a difference between the home and the theater. For movie, we need to look at the Greenhouse-Geiser correction here, but we still have a significant result, which means that there is a significant difference between the type of movie and reported happiness. However, when we look at the interaction between the two, we see that we have a significant F right there, which means that there's something going on. So it's not necessarily just movie and just location on its own that have an impact on happiness, but it's some sort of combination of both variables. So since this is significant, we don't care that these are significant, and we can actually just ignore the rest of the output. We don't need to look at the post hocs for this here to see exactly where the differences are because we have to do a simple effect analysis. So we can skip all these tables that came out for the main effect comparisons, and just if we want, go to the bottom here to look at what's actually happening with the groups. So group 1 is theater, group 2 is home, and we can see that we have non-parallel lines. So this would explain the significant interaction. So now we need to do the simple effect analyses to look at each of these. So if you recall, for the simple effects, we're going to look at just the location of, we're going to look at just the movie theater and see if there's difference between the types of movies. And then we'll look at just the home viewing and see if there's different types of movies. Then we'll look at just the comedy and see if there's differences between whether they watched at home or whether they watched at the theater. Then we'll look at just drama, same thing, and then just action. So those are the 5 simple effect analyses we have to run. So to do this in SPSS, it's pretty straightforward because if you recall, each of these groups already exist in the form of variables, and they're essentially just a bunch of repeated measures ANOVA that we have to run. So we have to look at just this, just that, then just these two, just those two, and just these two here. So we're going to close this, and we'll set it up to run the one for drama. Okay, sorry, not drama, rather. We'll start with the theater ones. The different movies depending on whether the theater or the home. So to do this, we'll do general linear model, repeated measures. This time we can take out the location factor. Okay, so we'll just remove it, and otherwise we can leave everything the same. So we're just going to be building one level of this, not both levels, and then we click define. So I'll reset this so you can see. So now it's like we're running a simple one-way repeated measures ANOVA. So we just have the 3 groups on happiness. So we'll start with the theater. So we have comedy theater, drama theater, and action theater. So what this will tell us is if just looking at people at the theater, are there a difference between the 3 types of movies? So at this point, since we have 3 groups, we do have to specify that we want some post hoc comparisons done. So again, we're selecting Bonferroni, and we can ask for the descriptive statistics and again the estimates of effect size. And that is all we need to look at. So we click OK. And I just realized we forgot to take note of what the mean square error was for our original model, but we can come back to that in a second. Okay, so what we have here is, so we have just the one group, just theater here. And at this point, it doesn't matter if there's an issue with sphericity because we're still testing our overall model and not just the simple one, so we don't need to worry about this. So just stick with whatever you would, the interaction had already assumed. So if the interaction had an issue with, let's say, sphericity and you were making a greenhouse Geiser correction, then when you're looking at the simple effects, you'll want to do the same thing. But for this case, we didn't have that problem, so we don't need to. So as we can see here, there is a significant difference between the 3 types of movies, and it is rather large because this F is pretty big at 73.979. We do, however, have to make an adjustment to this F and recalculate it based on what the error term was from our original analysis. And unfortunately, I can't remember it because I forgot to look, but we'll go run it again. But what we would do is you'd have to divide 48.8 by 0.66, and that would give you your F here. So we'll have to adjust the F, but we do need to look also at the post hocs. And what we can see here is that there's a significant difference between comedy and drama, and a significant difference between comedy and action. However, there is no significant difference between action and drama. And we can see that right here for people who are at the theater. Okay, let's close this, and I'll go get that error term that we were supposed to use. So I'm just going to rerun general linear model, repeated measures. So I'm adding the location factor back in. Okay, and oops, it switched because I have them in different order. It just switched up which one goes where, so you have to pay attention to the numbers. So this time we have comedy theater, comedy home, drama theater, drama home, action theater, action home. And let's click OK quickly. All right, so here is our mean square error term. Okay, so it is 0.589. So as you can see here, so this is the interaction term, and this is the error term for that interaction. So when we're doing our simple effect analyses and we have to adjust our F, it's going to be using this value as the denominator in the equation, so 0.589. Okay, So now let's go back and run the rest of our simple effects. So we have to go back to general linear model, repeated measures. We're going to take location out again, and now we're going to run the same analysis we just did, but for people at the theater. So we're looking at at home rather. So now we have comedy home, drama home, action home, and again we need to set up the post hocs. So we'll set this up here, and we can ask for the descriptives and effect sizes if we want, and click OK. So this time we're looking at home. We have the different averages here. Again, there's an issue with sphericity, but it doesn't matter because our original interaction did not have an issue. So now we're looking at just the difference between movies for people who were watching movies at home. So we have a very significant F here. However, if you recall, we have to recalculate this with 106.4 divided by 0.589 instead of 0.505 to adjust for the main error term. So it's going to change this value slightly, but it's still going to be significant because that's a very large value. Then we go back down here, and we have our post hocs, and this time we can see that all three groups are different. So it doesn't matter what kind of movie you're watching, there were differences between all the groups, and you can tell here, who was happiest, who was least happy. Okay, now we need to look at the simple effects for just drama, action, and the other side of it. So let's go analyze. Again, we're going back to the same spot, repeated measures. And this time we're going to just look at location. Okay, so we'll add that in. And this time we're going to take movie out. So we're going to click define. And so this time what we just need to tell it is that we want to look at the two comedies. And we don't have any post hocs to run because there's just two groups. So we can click OK right away. And what we're going to get is the effect size, not the effect size, wow. We're getting the F ratio for that, and we can see here that we have an F of 28.5. So there is a difference between the people who watch the comedy at home versus at the theater in terms of reported happiness. However, before we can be officially sure, we have to redo this calculation here with 0.589 as the denominator. However, the F is only going to go up because this 0.589 is much smaller than this value here. So there is a significant difference for comedy. And now we do it again for the next one. So we can click OK, reset. Now we'll look at drama. OK. All right, and the same thing. So again, this time the value is going to get a little bit smaller though because we have to divide 144.4 by 0.589. However, this value is so large that there definitely is a significant difference between the reported happiness for drama based on whether you watch it at home or in theater. And then there's one last simple effect to run here. Okay, so action, okay. All right. And again, it's significant, however, we do have to make the adjustment here. So 25.6 by 0.589, replace this value, but it's still going to be very similar to this, which is very significant, so we can conclude there's a difference in terms of reported happiness for the action movies as well, depending on whether you watched it at home or in theater. Okay, so that's how you run the repeated measures factorial and all the simple effects. Now we're going to look at how to run the mixed factorial. So now we're looking at whether energy varies during the day between the beginning, middle, and end, and whether there are differences between gender. So our first independent variable is time. So morning, basically start, or I think actually it was start of semester, middle of semester, and end of semester, and not a given day. And then gender is male or female. So we have three variables to represent the repeated measures variable, and one variable to represent the independent, because we're just separating the current participants into groups. So in gender's case, there are two, however, there could be way more than that. So since we have a repeated measures variable, we have to go back to the same options to run this. So we would go to General Linear Model, Repeated Measures. I can reset it again. So the first factor is going to be time, and it has 3 levels. Okay, so start, middle, end. We can add that. And we don't have to add the second factor because it's independent, so we'll be adding that later. And we're looking at energy. So we click Define. So we can stick the 3 of these in here, so energy start, middle, and end, and they can do 1, 2, 3. And then we're going to add gender as a between subjects factor. So what this means is we're adding it as an independent variable here. Sorry, not an independent variable, but an independently measured variable. So options are all the same. For the plots, usually it's easier to have each the repeated measures variable on the horizontal line so that each participant has its own line. So regardless of which one has more measures or not, usually you would want to put the independent measure on separate lines and the repeated measure on the horizontal line and click Add. For post hocs, this is where we would specify the post hocs for our independent measure, like right here, if needed. Gender only has 2 levels, so we don't need to, but if this was something like course section or music preference that had more, you would want to select this and click this. And we can do it anyway. You'll see SPSS will just say it can't do it. And that would be in the case where we don't have a significant interaction and we need to look at the post hocs for our main effects. Save, we can skip. Options, again, we want to select the Bonferroni post hocs. This is to look at the differences in time. And then we'll ask SPSS to generate descriptive statistics and estimates of effect size. And we also need to ask for the homogeneity tests for this variable if it has more than 2 levels. So in this case we don't need to, but I'll ask for it anyway. And we can click OK. Alright, so you see here already it tells us that the post hocs were not performed for gender because there were fewer than 3 groups. So that was expected. So now we have our between subject factor. We have gender, male and female, 10 and 10. And then we have the 3 levels of energy. So we have it divided by male and female and the total as well. So we can see already there are some differences here in the reported levels. So you can ignore this. So here are tests of sphericity. So this is looking at the sphericity in 2 things. One is the main effect for time, and the other, that's all it's looking at, rather. Sorry. My mistake. So just looking at the sphericity for our independent variable that is measured with repeated measures. So that's going to be time. Then we have the results. So as you can see here, we have the main effect for time, the main effect for time and gender, so that's the interaction, and the error for both. So since we have a repeated measure and since our interaction has a repeated measure in it, it is going to fall in the repeated measures table. So what we can see here is that there is no issue there is a significant effect for time. However, our interaction is also significant. So what that means is we're more interested in this than this. Let's just go see the rest of the table just in case. So you can ignore this here. And then these are the results of the Levine's test. So we can see that there's a little bit of an issue between males and females for energy start. However, if you recall, in these designs, as long as your groups are equal, it's not a problem. And you can see up here, the groups are very equal. So we looked at it, but even though there is a, that's not even a problem, but it's becoming a problem here, but it doesn't matter. And then here is our table for our the independent variable that is true, has independent measures. And we can see here gender has an F of 0.89, and this is not significant, or this is very much not significant. So we don't have a main effect for gender. But either way, we have to keep running analyses because this is significant, so we have to look at the simple effects. So we can close all this, but first we can look here at what's happening. So we can see that there's definitely something going on, and since we have some non-parallel lines, that would be probably why the even though they're not super non-parallel from each other, this would be why the interaction is significant. So we'll close this. So to set up our main effects, since we have 3 levels on one variable and 2 on the other, we're going to be, sorry, and I said main effects, I meant simple effects. We're going to be testing 5 simple effects. So The first one is pretty easy. If we want to look at the difference between males and females for the beginning, the middle, and the end, we just need to run a bunch of one-way independent ANOVAs all at once. So we do analyze, compare means, one-way ANOVA, and wait, oops, I forgot to get the error term again, sorry. Sorry, we'll just run this again. Sorry, we need our error term in order to make the correction. So you're taking the error term from the interaction. Okay, so it's 0.785. Okay, so the degrees of freedom and error term right there, 0.785. All right, so let's go back now. Analyze, compare means one-way ANOVA. So what we're going to look at is the difference for all 3 time points divided by gender. And at this point, there are no, we only have 2 levels here, so we don't have to set up any post hocs or anything. However, if we did, we would want to click Chef A because it's independent measure, but gender only has 2 levels. So right away, we can click OK, and it tells us that there were no post hocs performed because there's only 2 levels, and we have our results. So what we can see here is that there's a significant difference between the men and women at the start, however, not later on. If we were to adjust this for our real error term, which is I've gone completely blank. But anyway, it was 0.7 something, I think. So we would adjust this, and we would get a new value here, and we would have to check in the table to see if it's still significant for 1 and 36 degrees of freedom. And once we had that, we could confirm if there's still a significant difference. However, these 2 are probably not going to get any better and are going to remain non-significant. However, to calculate the F, you would have to replace this error term here with the error term from our original analysis. Okay, to get the other 2, we have to go back to our original measure, so general linear model or repeated measures. And this time, we would leave all this here and click Define. But all we're going to do is remove, oh wait, sorry, we have to do one thing first. We have to do data split file by gender. So if you remember this from last time with the independent factors. So we do this here, and then we go back to the original analyze, general linear model, repeated measures. So we click OK here, and all we need to do is remove this because we don't need to know these by group anymore. SPSS, since we have the split file on down here, is going to give us the answers for both groups. So since we have 3 levels, we need to keep our post hocs here. So we'll make sure this is still estimated, which it is, and then we can click OK. So this time, SPSS is giving us results for males and females. So we have the energy for males, energy for females. We can ignore this box here. We can ignore this as well. And then this is where we're really interested. So we have the repeated measures effect for males and females, and we can see here before we adjust the error term that they're both significant. However, we would have to redo this 56.63 divided by, I think was 0.7 something, and it would give you a new F statistic, same here, and you'd have to check in the table. However, based on the values we see here, I'm very confident that it would remain significant. So we can conclude that males and females reported different levels of energy throughout the semester. So now to see exactly where we have the differences, we would go down to our pairwise comparisons. So for males, when we looked at the beginning and the middle of the semester, everything was significant. So this is smaller than 0.05, so there's a significant difference. Same with beginning and end, and then middle and beginning and middle and end, everything's significant. So for males, there's differences between all 3, and for females, we see the same thing. So those are the other 2 simple effect analyses. Okay, so you should have everything you need now to run both the the full analysis for mixed factorial and repeated measures factorial, as well as the steps for running all of the simple effects in the case that you have a significant interaction. Okay. Thank you.